Okay, so here's the thing. If we can have such a thing as an absolute velocity through the universe, then by definition we have something that's being absolutely stationary, right? Because if you can determine absolute velocity, then we can determine if something could be absolutely stationary, which to us, what we do know is that that's not possible. And we can take a look at this picture here. Let's suppose this picture, that every single arrow represents the velocity of some object, a star, a rock, or a spaceship. Every single thing is moving relative to one another. Every single thing is moving, and even whoever's taking this picture is another camera that is also moving through the universe. So absolutely nothing is stationary, and absolutely every single velocity here is relative. So let's just think about if it's even feasible to determine such a thing as absolute velocity. I want to come back to Dialect's video here, which they have an example with two moving twins. Both twins are in different spaceships, and they both move away from each other at the same speed. But one twin turns around later than the other twin. Now, if you watch my True Solution Twin Paradox video, that kind of explains what exactly is happening and why they don't have symmetry. But regardless, let's think about this for a second, where you have one twin that moves more space, or more absolute distance, through space than the other twin, and therefore this twin ages less. Now, that is an interesting phenomenon, and that kind of goes into if velocity can be absolute. Now, keep in mind, even in this example, their origin point Earth is still going to be moving, right? So Earth is itself not stationary, not in absolute terms. It is stationary in relative terms, but not in absolute terms. So let's expand this video, let's expand this example and look at something else. So nothing is completely stationary. Nothing. There's no reference point that is stationary. So, in addition, there's no such thing as fast or slower, right? Because if nothing's stationary, we can't say who's moving faster or slower, even to these two. Now, you can see these two are moving in roughly the same direction, or sort of. However, to his perspective, so if we look at his POV, right, assuming he's the stationary one, he will simply see this ship moving the opposite direction, that way, to the left. So even to him, nothing is slower. He doesn't think that this ship he's moving faster than this ship. Now, another ship might think he's moving faster, but he certainly doesn't. He simply sees that ship moving the opposite direction. And in addition, this is just from this angle, and you can view this thing from a completely different angle, and then we'll see something completely different. We're moving this similar 2D. Remember, in real space, we're full 3D range of movement. So again, absolutely, we don't have any way of ascertaining who's moving and who's stationary, who's moving faster, who's slower. Except we sort of do. Now, remember, moving faster or slower. When an object is moving faster through real space, that object experiences more time dilation. We know that for a fact. And again, that's how we have the twin paradox, where we can resolve that. The more someone moves through real space, the faster they move through real space, the more length interaction they experience for the universe. And in addition, the slower their clock goes. Which means, in theoretically speaking, that there could be one of these ships that is experiencing the least amount of time dilation. Now, if that ship is experiencing less time dilation than everything else, then that ship presumably will be the slowest ship in this example. So could there be an object in this universe that is experiencing less time dilation than every other object? And therefore, that will be the slowest object in this universe. Now, that object is probably not stationary, but he is moving slower than every other object. Again, this is just a theory. I don't have a method of proving this, but potentially speaking, let's suppose that one object is moving the fastest. Let's say this one. Let's say this guy is moving the fastest. So every other object will interpret this object as experiencing the slowest clock. Slowest clock possible. Again, I'm not saying that I know this for a fact, but this is just, again, theoretical. Let's just think about it for a second, if that's possible. If they could see this object as having the slowest clock, or the slowest clock. Inversely, can we have an object here that every other object interprets as having the fastest clock? We know that through the twin paradox, where that is possible, where one twin will age less than the other twin. Then who is the one with the fastest clock? The one that is moving the slowest through real space will have the fastest clock possible. Can we find that fastest clock? Okay, so now, one thing to note is another way of looking at this is by measuring length contraction. Not from the object itself, but the object's interpretation of length. So here's the thing. We have these two objects. Now, this object thinks this guy is moving away from it. He thinks he's stationary. However, from this angle, we can see for certain that because this object is moving faster than this one, he will experience more length contraction of the universe. So he'll think everything is shorter than this object is. So, let's suppose that these two objects are going to look at a third object. That is a line. Let's say, like, long line. Now, we don't know the absolute length of that object, because obviously everything is moving, so all length interaction will be different. But because this object is moving faster than this object, then potentially this object would interpret that third object as being shorter than this object. Because, again, he's moving faster through absolute space. Exact same thing as length and time dilation, right? He sees more, experiences more time dilation. He observes more length contraction. So could he potentially view a third object and view it as being shorter than this guy does? In that case, then we can say this object is moving faster than this guy. Again, hypothetical, but that's another way of looking at the same problem. Okay, so we know that the Earth itself is moving in an orbit around the Sun. Now again, the Sun should probably also be moving, so we have no idea what the absolute velocity is. But we'll say the Earth is moving a certain velocity through space that we don't know. Okay, now let's suppose that one day we see an asteroid flying about this way. Now, this asteroid is moving to us on Earth. We're seeing this asteroid moving at a certain velocity. So to us, this asteroid is moving. But to the asteroid, the Earth is moving. Again, that we can accept, right? That's special relativity. But here's the thing. Let's make the assumption that what if this asteroid is actually moving less absolute velocity through space than we are? If this happens, then in theoretically speaking, we would be certainly more time dilation than this asteroid is in absolute terms. In addition, we would see that asteroid's clock speed up, while they would see our clock slow down. Again, this is a pretty profound question here. But here's the thing. What we do know is that, yes, technically speaking, if you just have a bunch of things, they're all that velocities and relative to each other, except time dilation is, in a sense that, again, when something's moving faster, that object experiences more time dilation. So, again, this triggers a lot of questions about how this all works. In a sense that, in addition, could there be a totally stationary object? If an object is completely stationary, then an object would experience less time dilation than everything else. Now, I don't think any object can be completely stationary in this universe, but we could say an object has less movement than any other object. How do we determine which object is moving slower? I mean, again, if we just have a bunch of objects, okay, I don't know the answer to that. This is just, something that just came up in my mind. I'm just expressing it. But look, you guys can think about it for a second and make your comments. But yeah, thanks for watching. Please share.